In this video, you'll see how to work with probability. First, we need to get some definitions. Probability is the chance that a particular outcome will occur, measured as a ratio of successful outcomes to possible outcomes. So one way we could do this is we can write a ratio, the number of successful outcomes over the number of total possible outcomes. Easy example to think about is if you have a coin, if the probability that you're gonna flip tails, you can say, well, when I flip a coin, there's only one tail, so that's just one successful outcome. But there are two total possible outcomes when you flip a coin, heads or tails. And there's a type of probability that we call experimental probability. That's a probability of an event occurring when an experiment was conducted. So that's when you actually conduct the experiment, whether it be flipping coins or checking rolling dice or something like that. A few more definitions to get to. Outcomes. Outcomes are the possible results of an action. So if I'm rolling a six-sided die, the possible results, the outcomes, are I could get a 1, I could get a 2, I could get a 3, a 4, a 5, or a 6. And then the complement of an event is the opposite of that event. The probability of an event and its complement is always 1. So if I asked you what's the probability that I would roll a 2 on a six-sided die, that's 1 out of 6. Well, the complement of that is the probability of me not getting a 2 when I'm rolling that die. Well, there are five possible outcomes that are not 2 out of 6 total. So that would be 5 out of 6. And you can see if I had 1 6 and 5 6, I get 1. And then odds. Odds describe the likelihood of an event. So the odds in favor of an event would be something like the number of successful outcomes. And then the difference here is going to be, instead of being out of the total outcomes like probability, it's the number of unsuccessful outcomes. And then the odds against an event, it's just a reciprocal of that. That's the number of unsuccessful over the number of successful. And then it's just helpful sometimes to look at this little number line when we're thinking about probability. If the probability is between 0 and a half, we say that that's less likely to occur. And if it's all the way at 0, it is impossible. And if it's right at a half, it's equally likely as unlikely. If it's between a half and 1, it's more likely to happen. And if it's all the way at 1, it is certain to happen. So if the probability of something is 100%, it is certain. So let's look at some sample problems. The probability of rolling a 3 on a six-sided die. Well, there are how many successful outcomes? That's probability successful over total. So there is one 3 out of 6 total. The probability of it being odd, well, the odd numbers are 1, 3, and 5, so there are 3 successful outcomes for it being odd out of 6 total, and of course we'd want to reduce that to 1/2. The odds in favor of rolling a 1, so rolling a 1 successful is 1. There's 1 successful outcome. Remember, for odds, it's not total outcomes, but number of unsuccessful outcomes, so there are 5 unsuccessful. Right? So if I wanted to roll a 1, if I rolled a 2, 3, 4, 5, or 6, those would be the unsuccessful. The odds in favor of rolling a multiple of 3. Well, when I'm rolling dice, there are 2 multiples of 3, 3 and 6, and there are 4 numbers, 1, 2, 4, and 5 that are not a multiple of 3. So I'm going to reduce that to 1/2. Alright, here are 4 for you to practice on your own. So if I have a deck of cards, and there are 52 cards total, 13 hearts, 13 diamonds, 13 clubs, and 13 spades, I want to find the probability of picking a 5. So it could be a 5 of hearts, it could be a 5 of clubs, 5 of spades, 5 of diamonds. So there are 4 5s in that deck. Out of how many total cards? There are 52 total cards. I could reduce this, and this will reduce down to 1/13. So the probability I pick something that's less than 5. So that means I could pick a 4, I could pick a 3, a 2, and I could pick an ace. So for each suit, there are 4 numbers that are less than 5. So I have to multiply that 4 times 4 because there are 4 suits. So that's 16 out of 52. And again, I want to reduce this. 4 goes into both of these. This is going to reduce down to 4/13. Now I want the odds in favor of picking a king or a queen. So there's 1 king and 1 queen in each suit, which means since there are 4 suits, there are 8 total kings and queens. So it's 8. Now it's not going to be out of 52, but it's going to be out of however many are not kings or queens. So that's going to be 8 out of 44. The way I got that 44 is I just took 52 and I subtracted the 8. And then I'm going to just reduce this. 4 goes into both of these, 2/11. And finally, odds in favor of picking a single digit card. So that's ace, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is going to be 9 for each suit. So that's 36 that are single digit cards out of a deck of cards, and 36 out of 52. So that's going to be 36, and then 16 are not a single digit card. So the way I got that 16 again is there are 52 total cards, and I subtracted the number that are single digit cards, and that's how I got that 16. I want to reduce this. 4 goes into both of these. This is going to be 9/4. And that's how we work with probability.